Hey, this is Kevin. Uh, I'm a software engineer at Google and an alumnus of the EECS program at UC Berkeley. Go Bears! And today I want to talk about LeetCode number 4, the median of two sorted arrays. All right, for this problem, basically what we have to do is we have two arrays. They're in order, and there's a bunch of different numbers in them, and we want to find the number that's the median, the middle, right? So like in this one, if it was one array, it'd be 1, 2, 3, and we would just take the 2, which is in the middle. And this one, if it was in one big array, it'd be 1, 2, 3, 4. The two middle ones are 2 and 3, and we would just average those out, get 2.5. And I think it's and also we want to do this in log time, right? So if it was, this is what makes it actually interesting, right? Let's say it was in linear time, it would be pretty easy. You could just iterate through the arrays until you got to the middle point and go from there. Cool. So I don't know if anyone has watching this has taken a look at the solutions. They're actually really complicated and long. There's a lot of math and formulas. So I'm going to try to explain it in a way that doesn't have so many math items. All right. Cool. So I think the first thing we have to think about is, let's go ahead and, all right. So let's say we have, I'm just going to take an example first, but let's just kind of pick this apart with an example. So we have two arrays, one with 6 elements, one with 4 elements. And we actually want to find a way to kind of split out the items so that they're, like let's say we kind of pick a pivot point, for example. Actually, let's pick the middle first to start. And now we have 5 elements on the left, 5 elements on the right, and we want to find a pivot point such that all of the elements on the left are less than all the elements on the right. So I guess you could say the biggest element on this side is smaller than the smallest element on this side, right? So that would just imply that it's in order. And if you can find a pivot point like that, you know that the median is going to be somewhere amongst these 4 numbers, right? Like if that was the case, basically this could look something like this, for example, right? Middle, y, y, x, x, x. It doesn't really matter, right? There's basically, we're splitting it up 5 and 5, and if everything on the left is smaller than this pivot area, and if everything on the right is bigger, then we know that the actual median is going to be somewhere in here, right? It's basically going to be the average of the two that are the closest. And if we're splitting it up this way, we're going to know this guy and this guy, and this guy and this guy. The ones that are that are next to the point where we're splitting it up. So I'll just mark those out here too. So that would be this and this, for example, right? So we know from the pivot the x one that is the closest and the y one that is the closest. And we can see then that we already know if this is fully ordered, right, that our median would just be the average of the two middle points, x and y. Or if it was an odd number, then let's say there was one more element, for example, it would just be this element, the smaller of these two that we already know. So if we can find this pivot point, we can essentially do a constant time calculation to find the final thing. So yeah, so let's just mark this down. Finding a pivot point where all elements to the left are smaller and all elements to the right are greater. You basically you can find the median. I mean, it's essentially the definition of the median, right? Like everything on the left is smaller and everything on the right is greater. So I think this is pretty straightforward. Cool. And then the next point I want to illustrate is, let's see, it's like this. All right, we have one short and one long array. You can basically pick any point on the short array. Again, we'll pick the middle. And there's a corresponding point on the longer array that splits it up so that there's the same number of elements on both sides. We don't know if this is the right point that makes it so that this part is true, but we can split it up so that there's the same number on both sides. So let's say we pick this one. there's 3 and 1. So then to make it add up correctly, we would pick that point, right? So then if we lined it up, now the right side has 5 and the left side has 5. Okay, we could also, pick the end. And so then if we were to line it up again, it would be like that. So there's 5 and 5. So basically, you can pick, or any pivot point in the smaller array has a corresponding point on the large array. Large array that divides the total number of elements in 2, right? So basically, if we know that, we know that in the small array, we can basically just iterate through then and check each one of these guys, right? These pivot points, and just get the corresponding one of the larger array, and then we can kind of we can just check all those points to see if we are at the median. And then the next point is there actually is a to find this median, the one that is the correct point that divides all the elements that are to the left are smaller and all elements to the right are greater. You really just need to check, wherever you pick the pivot point, you just got to check that out of those 4 elements that are, adjacent to the pivot point, you already know that this x is going to be smaller than this x, right? Because you already know x is this x and this x, so this is the ones that we're talking about. We know x is smaller than this x. This x needs to be smaller than this y, and this y needs to be smaller than this x. We already know that this y is smaller than this y, so it basically is just like there's only 2 checks really. We just need to know if this guy is smaller than this guy, and this guy is smaller than this guy. And what we can do is our strategy would be pick a bunch of different pivot points, do that check, and we can confirm whether or not we have the right pivot point. But then we can also, there's another point too to this, is like when you pick a pivot point, if it doesn't work out right, you can actually know which direction to move. So that's another. So like let's say, for example, let's put some numbers together. Let's say we pick this pivot point here, right? And so there's 3, so there's 3 on one side, 1 on the other, so it would be like this, 5 and 5, right? Is the 4 smaller than the 3? If we were to divide all these elements on one side and these on the other side, would it actually work? No, because 4 is bigger than 3. But if we do it this way, 2 to 5, this actually works. 2 is smaller than 5, so that one works. But from 4 smaller than 3 doesn't really work, right? So if you were to make this into one array, it would be 1, 2, 2, 3, 4, then 3, so it's like not in order, so it doesn't really work. But we know, because this is larger, now we can know which direction to move in. So since the 4 is bigger than 3, we need to actually pick a pivot point in the smaller array that is bigger so that we can get closer to our thing. So then let's say we were to move over to here, right? Now we have 3 on the left, so it would be like this, right? And again, we can do the same check. 2 to 5, okay, 2 is smaller than 5, that's fine. 4 is bigger than 3 again, so now the element in the smaller array is too big. So now we know we have to go to the left in the smaller array. So it's possible now to determine, so if we were, we'll go left, we'd go here, right? We already checked this one, we already checked this one. This is the only thing left that's in between those, and then boom. Now it actually works. 3 is smaller than 4, 3 is smaller than 4. Cool. So after picking a pivot point, it's possible to determine whether we need to go left or right All right, cool. So this is like, it's starting to come together, right? You know that you can pick a pivot point on your smaller array, and then you can find the corresponding large pivot point on your larger array. You know from that pivot point, it's possible to determine whether or not you need to go left or right to find the correct pivot point. And once you have found it, you know how to confirm it, right? It's just, this one has to be smaller than this one, this one has to be smaller than this one. So that's basically it, I think. I mean, it's kind of like the main idea behind the solution. So the strategy could basically just be, okay, check each of the pivot points possible in your smaller array, find the corresponding larger pivot point or in the larger array, check if it's correct. If it's not, move left or right until you find it. And if you're doing this problem, right, this is a LeetCode hard, you might be familiar with the idea of binary search. So essentially it just boils down to, you can just do a binary search on the smaller array. Essentially you just pick the midpoint pivot, you know to go left or right. If you're going to go left, then you only have to check these pivots, and then you just keep going to the midpoint until you have found the correct pivot. And once you find the correct pivot, then you can just calculate the final median in constant time. Cool, so let's go ahead and just mark this out. Let's kind of outline this out. So I've already prepared the code for this, so I'm going to go ahead and just kind of give it a little bit of kind of a basic outline so that we can make sense of it. All right, so binary search elements. Let's actually call this code outline. All right, so we need something to, we're going to do one binary search on small array. We're going to need a method to, once we have our pivot points, just to, I'm going to call it like this. So I'm going to actually name each of these points right here. It's going to be called left on the long array and right on the long array, and left on the short array and right on the short array. And these are going to be my indices of these guys. And so we can basically do binary search in the small array, get from the midpoint, we'll get the indices. So it's going to be called, L long, R long, etc. We're going to do get direction, and that's going to give you you pass in the indices, and then it's going to tell you whether or not to go left or right. And then we'll do something called get result. And this is just once you have your indices and they're correct, it will output the median. So it'll look something like this. Cool. So let's do the implementation. Okay, so the first thing I want to do is let's make sure we have a clear way to determine what is our short and long arrays. So let's call it array short, array long. Just arbitrarily assign these, and then we can this. Okay. All right. So we'll arbitrarily assign them to short and long array, but if the nums1 is actually the long array, we'll just swap it. So now we know in array short and array long which one is our long array and which one is our short arrays. Next, I'm going to do binary search on the short array. So we're going to have two indices. Array short. Okay. While something, don't ever do this while true. I will replace that in a second. But we're going to do the midpoint is the R over 2. And Um, we're gonna get the direction. All right, so like get or actually from the midpoint, get our indices, determine our direction. If our direction is less than 0, then r equals m minus 1. Well, if d, actually let's say like s, if d is greater than 0, so it's basically going to be minus 1, go to the left, plus 1, go to the right. And we'll just keep updating our midpoint, and then when d is actually equal to 0, we can break out of here. So something like this, and then we'll break out, and then we'll do our calculate median outside of the loop. So something like this would be our main skeleton of our code. Cool. And then one thing I wanted to also just mention is when you're picking a pivot point on your short array, it's possible to also pick a pivot that's like on the side right here, like this. So some of these indices might actually be like, so this is going to be index 0, 1, 2, 3, 4. You can actually have -1 index and also 5, right? So it can just be off the end of the array. So I'm just going to kind of put together a little helper function so that when we get to that, we don't error out. So I'm going to call it getVal. And so accessing index I within the array, if I is equal to -1, then return float, -infinity. And the reason we're returning -infinity is the array is supposed to be ordered, right? So this is in comparisons, the -infinity will always be less than any other integer. Okay. Return positive infinity if it's off the, if the index is the very front of the array, return the -infinity. If it's off the end of the array, return positive infinity. Otherwise, return array at the index. And so instead of accessing the array directly, I'm going to access all the arrays through this helper so that we can kind of get these things in there. So this is going to get value at index I of array R. Cool. And now we want to define get our indices. So define get indices. And we calculate our midpoint here as somewhere within the array. So, but we actually have 2 points within. When we create a pivot, we actually have 2 points, right? It's like this. So we're just gonna have to kind of just pick one. I'm gonna just have it be on the right side, and I think you'll see why in a second why it'll be helpful. But it's gonna be on this one right here. It's gonna be the R short. So when you pass in R short and your short array and your long array, then calculate the rest of the indices, and you want to return your left short, your right short, your left long, your right long, right? Return those items. Cool. So you've basically picked some index, right? Your m is going to be, let's say your m is, we're looking at this index in your small array. And so if it was this case, it would be 1, right? And basically what the index also tells us is the number of elements in our short array that are going to be on the left half of things. So let's say we put our pivot here. The index is 1, there's 1 element to the left. We put our index here, there's 2 elements to the left. Okay, so in order to get, now we need to kind of calculate the corresponding midpoint here. And so how that would work is basically you would have the total number of elements is 10. And so it would get 10 divided by 5. We have the 5th element, 1, 2, 3, 4, 5. So it's this guy. Actually, 0, 1, 2, 3, 4, 5. So actually it's this guy. And we're going to basically say, okay, but if we choose to put the pivot right here, we also have one element that's to the left, right? So we actually just move this over by 1. And that's kind of like how we would do our calculation. So essentially it comes out to be your mid-index, I guess you can call it, equals your length of your short array plus your length of your long array, divide that by 2. And this is in Python too, so it's going to be integer division, so it'll round down. And now we know that that's our mid-index, so we know that the r long is just going to be that mid-index minus r short. Right, so there's one element, if we pick the index here, there's one element to the left, and then 0, 1, 2, 3, 4, 5. Oh, sorry, it's actually this one. Wait, is this right? 10, 5, 0, 1, 2, 3, 4, 5. Yes, it's this guy. Minus 1, it's this guy. So the corresponding pivot is here, and we have 5 and 5. So, if you have, this isn't a super complicated calculation, but if you don't believe me, go ahead and maybe pause the video and take a second to prove this to yourself. But anyways, here's how you would calculate that r long, and then we would basically, now we have r long, we came in with r short, we already know that indices of the, we have these two, r long, r short. The L long and L short are just minus 1 from each of those. So we'll go ahead and return r short minus 1, r short, r long minus 1, r long. Cool. So let's do this. So we have these 4 equals get indices with m, a short, a long. Right. So all I'm doing is getting indices from our m. Okay? Cool. All right. Next, we want to determine which direction we want to move. So let's this one. Determine our direction. We want to output whether we're going to go left or right, or if this is the correct direction. So again, we'll pass in each of those indices. Let's just copy this in. And I just like to do pass by value here, so that's why I have to kind of have all this in here. But you can also, you don't necessarily have to do that. You can actually just have these functions access the, the outer scope and just manipulate these indices directly. But I think it's a little bit cleaner for the namespace if we pass by value. But anyways, all right, well, and we'll pass in the arrays as well. And so this is where we do that crisscrossing check, right? Like this guy has to be smaller than this guy has to be smaller than this guy, and if not, we know we're going to move left or right. So if a short at L short is, it's supposed to, if it's greater than a long at right long. So that's here, L short. If this guy is bigger than this guy, then the index that we've picked on our short array is too big, so we want to go to the left. So that's going to be turn -1. Okay. Else, if a short, let's actually go a long of L long is bigger than a short at R short. So now, from the long array, if this one, right, L long, is bigger than this guy, then we know that we've picked an index on the short array that is too low, so we want to go right. So we'll return 1. And otherwise, we're just going to, we know that we have actually picked the correct index, because those are the only 2 checks we need to do. We just need that crisscrossing check from here to here, from here to here. So yeah, we would return 0 if we were in a good position. So, oh, you know what? I forgot to mention, since we are also going to be able to go off the ends of the shorter array, this is where the get val would come into play. So let's actually replace these with get val. Right, and so this just protects us if we go off the ends of the array. Okay. And this one, I feel like I'm using get val a lot. I didn't want to pass too many things, so I'm just going to have it actually, was this a long, passed in from the global scope instead of passing it in by value. Okay. All right, cool. I hope I got all the little things correct here. Okay, cool. And then let's see here. So now we can take this get direction, put it in here. And we can say direction equals that. We already have our binary search directions, right, moving. If we get 0, it'll just get to the end of this and it'll break out of the loop, so then we're good. I think I used a few. Let's actually initialize these variables. Also didn't initialize D, so binary search. And let's call this temporary variables. And D. Okay, this just could be anything. Just so we have them. Okay, cool. Because they're all being set to some values here, so before they get used, so it doesn't really matter what we initialize them to. D just can't be starting at 0 so that we can get through this first while part check. So get indices from our M, get direction, get our D direction, go either left or right, and then we'll just continue to the binary search until we find the right set of indices. So yeah, I think if we break it down this way, it's actually, none of these little pieces of code are actually that complicated, right? Each one is only like 5-10 lines, just kind of breaking out this bigger problem into smaller parts. All right, so then the final thing is, now that we break out of this while loop, we know that we have L short, R short, L long, R long, and they're the correct indices in our long and short arrays. So how do we find out what is our actual median? So let's put that guy in here. So let's call it get result, and we'll pass in all the same stuff. Okay. This is so annoying. The thing I hate about binary search, or in the case of the median, I mean, is that sometimes with the odd you have to. It's annoying because you have to have a different use case for the odd versus the even numbers. So first we got to find out if we're doing an odd. We have an odd total number of elements, and if odd, we do something. And if we're doing even, we do something else. So let's think about this for a sec. Let's do the even case first. I think that's probably a little bit easier. So in the even case, we have something that splits out this way, right? Even number of elements on the left and the right. So we have these 4 elements that we know what they are, and we just need to know what is the one that's like the biggest one on the left side and the smallest one on the right side, and just average that, and we know that's our median, because our median is somewhere within these 4 points. So for the case of the even, it's actually pretty straightforward. what that's going to be is return your, all right, you want to get the biggest one on your left side, so that's going to be max of get val something and get val something else, right? And that's going to be your a short, L short, a long, L long. And basically what that is your left side of your short array and your left side of your long array. Find the larger one of those two. Add that to get val something, get val something, these parentheses. All right, cool. And then this is going to be your right side of your short and your right side of your long. And then you take this whole thing and divide by 2. 2.0 Python float, so we can make sure that we get the decimals. It's just converting the integer to a float here. But yeah, so basically we're getting the max of these two, whatever is the bigger one, and the min of this and this one. And we know that those guys are going to be the ones that are adjacent to our kind of like abstracted pivot point. And that's what it is for the even case. All right, let's go through the odd case, which is a little bit more challenging, slightly, not too bad. I didn't actually put any examples of the odd case here, so let's do one of those. So for the odd case, let's do it like this. Maybe it's, yeah, so 5 and 4, for example. Let's just pick some random pivot point, like right there. And so it would be like, is that right? So yeah, it'd be 5 and 4, off by 1. And let me just go over how do we know we're on this one versus. So when we find our indices, we have our get our indices here. We have your total number of elements divided by 2, and so in Python, let's say you had an odd number of elements, like 11, for example, or actually, what is this one? 9. So 9 over 2 as an integer ends up being 4. 4, yeah, because it's actually rounded. It's floored, so it's rounded down. And we had said earlier that we're going to take our r right, that's going to be this midpoint minus the index of your r short. So in this case, it's 1, right? There's 1 to the left, so it's 0, 1, 2, 3, 4, minus 1, so it's here. So when it's the odd case, we're going to end up with 1 extra element on the right than on the left. So let's call this odd case. Okay, and we get, these are the 4 elements that we get, right? And so now our, let's imagine if we had the sorted array, it would look something like this. Y, or it doesn't really, we don't even know really, it could be like this, right? Oops. X, Y, whatever, Y, X. We don't really know. But we just know that there's a pivot point here, and the left side has 4, and the right has 5. And if that's the case, then now we know that our median is just going to be this element here. So it's just going to be the smaller of the 2 right side ones. So that's all it is. It's pretty, actually even easier to calculate than the even case. It's just harder to come up with. So that's what it is. So that'll basically just be the min of, there's 2 things here, get val of a long, r long, a short, r short. Yep, and that should basically be it. And then at the end, we're gonna just do get result. Boom. Turn this guy. All right, so comment this a little bit. Determine whether to go left or right, and get result. Calculate median. Okay, cool. Just putting everything together so that later, if you want to just see the whole thing, you'll have it in one place. So let's just try and run this. Syntax error. What is the syntax error? D greater than 0. Okay, what is that saying? D is less than 0, else. Oh. None is not valid type for the expected return type double. Line 129. 35. Turn. Oh. All right, cool. It worked for this one. And what was the other test case? 3 and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. Run. Cool. Oh no. Infinite. Right. What is that? Infinite, infinite, infinite. X. This should be min. So many bugs. All right, cool. Ta-da! All right, it worked. So as you can see, there's a few small bugs, but I think when you get to the interview, I think what's really more important is discussing this and then kind of proving that you can do some of the implementation. Hopefully you can do all of the implementation. I don't think that there would really be a problem that is this complex on an interview, or for them to expect you to do a full implementation. I think they might be okay with some pseudocode even, but essentially this is how you would do this in this binary search problem. Cool, and then also let's just quickly talk about the time complexity of this one. So again, we did the bulk of our iterations is here in the while loop, right? And this is a binary search, so essentially we, let's say we start with 10 elements, then we have 5 elements to check, and then we have 3 elements, and then 2, and then 1. So it basically just divides the number of elements you have to check by 2 each time, so that's going to be time complexity of big O log n. And then space complexity, I think we actually did everything in place, right? So yeah, we just do a bunch of kind of, one-time calculations. There's no additional real data structures. So the space complexity is big O of 1. Cool, so we met the constraint. Oh, one other thing I'd point out is also the time complexity is log n, where n is the number of elements in the smaller array, since we are doing binary search on the smaller array, right? So we are only, if one of the arrays is way smaller, we don't have to binary search through the big array. So here's the full thing, time, space, here's the full code. Can I get this in one screen? Oh man, it's big. But here it is. Here's all the helper functions and things. Here's the binary search part. Cool, so hope this was helpful. Yeah, try to, if you didn't get this all the first time, no worries. Maybe you can pause it or watch it a second time to kind of slowly digest it. I promise that it will sink in over time. All right, best of luck on interviews.